Hello, welcome back to my continuing series of videos for Calculus BC at San Ynez High School. This is for section 9.4 from the Kennedy book, Interval Convergence and Radius of Convergence. So you'll notice though that the first thing we need to learn is how to determine whether a series converges or diverges. The first test we'll look at is the nth term test. Now the nth term test is actually a test for divergence. If we have a series, and you can see this is a series, the summation from 1 to infinity of a sub n. If we take the limit of the nth term as n approaches infinity, if that limit is not equal to 0, then the series diverges. So the nth term test is only a test to check to see if a series diverges. If the test does not prove divergence, the series may or may not converge. So it may still diverge even if it passes this test. So let's go ahead and look at an example. It's easier to understand these with some examples. So here's a couple of examples. Let's determine if the following series converge. So we'll take a look at the first one. The first one here is the summation from 1 to infinity of n over 2n plus 5. So if we take the limit of that, I'm not on the right limit layer here. So if I take the limit of this function, sorry for that delay, limit as n approaches infinity of n over 2n plus 5, we can see that that is actually heading towards 1 over 2. So that's not equal to 0. And so the limit of this thing, again, is not equal to 0. The series, therefore, diverges. Okay, so if it fails this test, the nth term test, then we know for a fact that the series actually diverges. Let's take a look at the second one. Again, we take the limit of this, of the nth term as n approaches infinity. This time our term is 1 over 2n plus 5. So you see it's a similar thing, but not quite the same. See, if we take the limit of that, that actually is approaching 0. So what that tells us is the series may converge. Okay? We don't know for a fact that it converges, so it may still diverge, but it may converge. All right, so that's the nth term test. The next test we want to take a look at is the direct comparison test. So the direct comparison test is you actually compare a series that you're looking at to a series that you know something about. So if you can show that a series that is known to converge is greater at every point than the second series, then the second series also converges. Again, so you know a series converges, and you're saying that my series is bigger than that other series, so therefore we know that they both converge. Conversely, you can show that if you can show that a series is known to diverge is less at every point than a second series, then the second series also diverges. Again, easiest to look at through some examples. So let's take a look at this example here. Let's determine if the series converges. Now, if you look at this series, it would look very similar to 1 over 3 to the n. But I would know, in fact, that this series is always smaller than 1 over 3 to the n. And if we look at what 1 over 3 to the n is, 1 over 3 to the n is actually a geometric series where the first term is, so 1 over 3 to the n, if we take the sum of that one, let's write out some of the terms. The first term would be 1/3, and then 1/9, and then 1/27, and so on. So you can see this is just a geometric series where the ratio is less than 1. So in fact here the ratio is equal to 1/3. So this geometric series converges. Okay, geometric series. Oops, I can't write. So there's a geometric series where r is equal to 1/3, so the series converges. All right? And then the final part of this is, since 1 over 3 to the n, that series would converge, then 1 over 5 plus 3 to the n would also converge, because this series is always lower at every point than that series. That's because the denominator of this one is larger than the denominator of that one. So we know that this series converges. And it converges by the direct comparison test. So there we go. That's our work. There's our logic. And that's the first of our two tests. First two tests of our mini tests for convergence. Please make sure to come back and to watch my next video. I'll have some more videos for section 9.4.